Saurav sir. In this I have defined about a loan classification project, and it defines about the usage of supervised learning and unsupervised learning. Here I have used the modules of Jupyter such as NumPy, which are based on Python, and Pandas, Matplotlib, and Seaborn. These are the basic concepts which I have used in this, and this is import sklearn, model selection, linear model, and sklearn.tree, which are important for distribution of data, for forming categorical structure of the data, and decision tree classifier for distribution of data. And I have also used the reference of confusion matrix, which consists of true, negative. In this project I have used scikit-learn, which is used for machine learning tasks like splitting the data, building models, and evaluating performance. And sklearn is important because it consists of three important things, that is train, test, split, which splits the data into training and testing data set, logistic and decision tree classifier, which are used for models prediction, and last thing is confusion matrix, which consists of evaluating the model performance. I have used warning filter warnings, which is used to hide the unnecessary warnings for a cleaner output. And then I have imported pandas to read the particular CSV file, which is known as loan detection, which is as provided by the mentor. In this I have tried to summarize the whole data, which consists of age, campaign, days, previous, and lots of data, which is as shown in the table. In this I have tried to perform basic analysis, which is known as EDA analysis. Its full form is exploratory data analysis. And to summarize the whole data, means counting of rows and columns, I have used the function df.shape. df is related to pandas as we know that. And then since I came to know that it consists of 40,188 rows and 60 columns. And now I have tried to define the name of the columns by using the df.columns, and this I have able to get those columns. Now I have used df.info to find out that how many of data is integer, string, or any other data type. Since I have used df.info, it shows that all the data is of integer type, and then I have tried to describe it again to get proper view of the data. I have separated df.age because since it is an independent data, it does not depend upon the basis of loan classification. So I have done the value of counts because it will help us to confirm that if there is any unusual or unrealistic ages, and the highest ages are 31, 32, 33, and 35. And this presents some high like 90 to 98 indicates outlier of the data, which I will explain further on in this project. Now I have tried to use df is null.sum because this checks how many missing values exist in each column, and output that shows 0 is full for all columns, which means the data set is completely clean and no missing entries are there. It is better, which means that we don't need to perform imputation and other like data filling and instructions and all. Now in this section I have used the looping for df columns by using the pandas value. This loop checks every column for missing or null values. It prints only those columns which have missing values. And other thing which I have used is about the statistics concept as defined in the class. It is used to find a mean and median. and it also uses SNS.displot. And then I have used df.correlation, which shows how strongly each numeric value is related to each other. And the basis is that if it is +1, it is showing strong positive relationship. If it is -1, it is showing so strong negative relationship, means no relationship at all. And 0 is for showing weak or no relationship. Now in this project I have used matplotlib.pyplot and cbond to show various tables regarding columns. In this, I have used the loop which goes through every columns in the dataset, and it skips age with the help of pass variable. For each column, it prints the column name, plots a box plot using sns.boxplot as it is given here, and it shows the plot with the help of plt.show. So since I have described the table in previous codes, so here is the output I have used, which shows the outliners marked. Since in every column it is varied, so just like job housemaid, job entrepreneur, job management, job retired, and many other has less outliners as predicted from the above, which consists of, for example, previous, P days, and campaign. I have tried to symbolize, and here is the Marshall merit also located. And then I have used the concept of IQR. Now after detecting the outliners, I have used IQR, which is known as interquartile range. It is a numerical way to confirm what we saw visually in the box plot. So here each line does different work. That is, Q1 is known as 25 percentile. It shows 25% of the data, which is represented by 0.25, and quartile 3, which is known as 75 percentile also. It uses 75% of the data, which shows the value below 75% data of the lines. So here I have tried to print the interquartile range values. Here age, campaign, P days, previous are also showed here, which means that for age, the middle 50% of the data have 15 years. For campaign, the range is 2, meaning people were contacted 2 to 3 times, and hence it is as shown here. Now I have used X variable to drop the loan status label 1, and then form a variable where it will store the loan status label as shown, which I have used to drop the table. Here I have used the X to show representation that loan status label is not available here, and then I have used Y to show the loan status label is available. Now I have taken out the loan status because it is important to split the data, and it is independent, so it is of no dependent feature. Now here I have tried to split the data with the form of variables such as xtrain, xtest, ytrain, and ytest. Here train test split concept is used, where I have chosen the test size to be 20%. 20% will be learning data and 80% will be the training data. And I have used random state 42 because it keeps the result consistent each time the code is run, because if we will not keep the random state, it will randomize the data up to any numbers and it will affect the accuracy. Now I have used every variable xtrain, xtest to show the data it has gathered. And now I have used sklearn.preprocessing, which imports standard scalar class from scikit-learn and standardizes the numerical data. Here I have used sc.fib transform, which are used to calculate the mean and standard deviation for each feature in the training data. And then I have used the xtest for sc.transform xtest because it uses the same scaling parameters on the training data to transform the data set. It ensures consistency and it puts the training data and the test data on the same scale. Regarding the previous thing I just explained about a transform concept, the main thing is that sc.transform, as I explained above, is used to calculate mean and standard, and then transform training data so that each feature has mean is equal to 0 and standard deviation equal to 1. It puts both the data in the same scale because many ML models perform better when all input features are available on the same scale. Without these, it will have very different ranges which can bias the model, and as it is normally known, data biasing. And now here comes the main part where I have defined xtrain transform and xtest transform. We are seeing the input of the scale data where decimal values are represented in scientific notation, and it confirms that our feature scaling known as standard scaler is working correctly. And after applying standard scaler, both training and testing data are standardized, as I have told now. And now I have used the model selection where I have defined the splitting of the data as I defined above. Here the part of the project builds and evaluates a random forest classifier which are used to predict the loan and approval status based on customer data, which I have provided data as given above as per the project. Now I have used loading and preparing of the data where I have imported loan detection CSV, and now independent variables that include features like job, education and age are used, and target Y loan status variable is used. I have split the data as I have done above. Now model creation and training. Random forest classifier I have used here where it builds multiple decision trees and combines their results for more accurate predictions. The model is trained using rf.fit. lr.fit. Here accuracy is calculated using lr.score, as I have used here. Now I have used to print the accuracy of the scores in multiplying by 100, which gives a proper round off of training and test accuracy about 90%, which shows that it is great to use this model for this data. Now I have done about the selection of the data. Now in this section I have tried to evaluate the random forest model using accuracy, confusion matrix and classification report to understand how well it predicts the loan approvals. Here I have defined the code from sklearn matrices, import classification, confusion matrix and predict xtest sc. The trained random forest model predicts the loan status for the test data, and these predictions are then compared with the actual values of the y-test to measure the performance. Here the confusion matrix is as defined as follows, as 7203, 100, 759 and 176. Here the precision is shown as follows. Here it represents the true positive value, true negative value, false positive value and then false negative value. This model performs well with a higher number of correct predictions. It is possible only when true positive plus true negative are higher than the false positive and false negative. Here I had tried to visualize it using import seaborn as SNS and import matplotlib.pyplot. It represents the heat map and confusion matrix of y test, y predicted value. I have chosen the color blue and here is the confusion matrix. Here it is defined as 7203, 100, 759 and 179 as I have used in this program. Now come to the coding part. I have used a not true because it shows numbers inside each box. It is type of function which shows the number inside the each box, and then I have quickly picked up the model, split the features as it is does not doing refreshes all the time and forgot the data, so I have done the same step again, and then I have evaluated a random forest accuracy which is about 88%, and then I have used sklearn.ensemble and imported random forest classifier to create and train model and then evaluate accuracy of that model. Now after defining the classification table, I have used classification report which is important based on four important things, that is precision, recall, F1 score and support. Precision is formed on true positive divided by true positive plus false positive, and recall, which is also known as sensitivity, is based on formula of true positive divided by true positive plus false negative. F1 score, as we know, is defined as harmonic mean between precision and recall, and support is number of actual occurrences for each class, which is defined as shown above, 73083 and 935. Here I have used accuracy about 88.7%, 89% and macro average as shown here in the screen. Now I have defined important classifier projects, and then I have defined, after splitting of the data, my important coding. Here I have used the concept of important classifier. It shows which factors most influence the loan decisions and saves train model for future use. Here it is known as the final step of my code, and it had most influence on model decisions and saves the pre-trained model for future purposes. Here I had trained a model using decision tree classifier. Class weight is balanced, which are used to make the class balanced rather than imbalanced, and then I have used accuracy and report to print in accuracy of score, and it tells us about which import variables influence the model prediction. For example, top features include such as speed, age, contact and many other things. And then I have used data visualization here, which shows the top 15 features of the data as given in the output, and then saving up of model is saved. This model is saved in PKL format using Pickle, which is meant to be used for prediction without retraining. So that was my decision tree classifier project. At the end, I would like to say that it made me use the coding skills and improve it further on for many projects above ahead. I will try my best to create many more in the future. Thanks for this lovely project.